Good morning, good afternoon, good evening, wherever you are. Welcome to Azure Back to School. Let's get started. This is my daughter Sophia. This picture was taken when she was 6 years old. She loves Lego. And we attended this Lego conference, and I told her it's like build a house, from these pieces. And this is what she built. I am happy, and it's really nice, really cute. And of course, a few years later, since she enjoyed Lego, uh, she wanted to buy this kit to build kind of like a small dollhouse, and she built this in a few hours. And my point here is that there are creative ways on how to build pieces of of architecture or Legos or Mega Blocks, right? There's the one where you start from scratch, from from Lego pieces, or you have something that has kind of like a instruction where you can build more complex Lego builds. Today, I will be talking about managing Internet of Things devices in Azure the simpler way. My name is Ron Dagdag, and I am a Microsoft MVP and a director of software engineering at Spacey. Let's get started. So, our agenda today is we're going to be talking about what is Internet of Things. I'll talk about IoT Central, which is an Azure offering managing devices in Azure. There is also the device template that I will be talking about, IoT plug and play. How do we visualize our data and how do we integrate it with other Azure services? What is IoT? IoT can be summed up with these three things, right? You have a thing that's sending data to the cloud, and what you use that data to transform it where you can use it for business applications, or not just business but maybe home automation. So Internet of Things is network of connected devices and objects that sends and receives data over the internet, or can communicate with other devices or other systems. IoT devices have sensors that can detect and measure different ambient conditions, and how you use that data, the data that you collected, you would use it for either live monitoring or analysis or some decision making. There are two goals that you want for an Internet of Things system. One is remotely monitor or control that device. Remotely monitor is when you start gathering that data, or sometimes you might want to do some device processing where you process your data at that device, or you know the device status. Another one is through controlling that device. It's when you send the device from the cloud to the device and set it, like, set device property or reboot or do some other updates. Typically, when you start uh, want to learn more about Internet of Things, and there's a lot of resources out there on the internet, and they tell you, hey, start with a Raspberry Pi or an Arduino. A lot of the maker kits out there that gives you uh, a gateway to learn more about Internet of Things is based from a lot of these two examples. But the industrial Internet of Things, or the commercial use or the business application of Internet of Things, think about it as in not just in the factory or retail store or all these large scale systems that you have to communicate with all these sensors, and they have to monitor each one of them. And so, what are the different attributes of a successful Internet of Things solution? One is through scale, right? And then when you're building an IoT solution, you got to make sure that the services that you use in the cloud can scale, not just storage. Sometimes it's compute, sometimes networking, even multi-tenancy, because you may be having multiple systems. Another one is device management, and how do you provision each one of the devices? The life cycle of each device. How do you uh, disable, enable them, and updating software updates or OS or firmware updates on each one of these devices. You also have to think about big data management. This is when we talk about the data that we collected from this device, we send it to the cloud. How do we store them, right? Is it hot path? That's when we start talking about hot path, warm path, or cold path, meaning how long will you access this again, right? If you need to access really soon, you want that data to be quote unquote hot. And of course, if you want it for reporting or long-term storage, you might want to store it in a cold path, in a cold storage, meaning it in a way it's longer to access a read back when you need it when you need some reporting or analytics. So you also have to think about analytics, insights, or extensibility. This is when we talk about business rules. How do you automate some of the actions and integrate with other you know dashboards and creating all these different dashboards. High availability and disaster recovery. Of course, since you're you're depending on the application, Internet of Things application, some of them can be mission critical. Think about the factory. If you're having trouble with it, you can make sure it's reliable and resilient as you collect these data. So another one is security and compliance. This is when we talk about connectivity, integration, and data protection. Think about some of these IoT edge devices. It is actually closer to the user. It might be something that they wear or something um, uh, that can easily get stolen. So you got to make sure it's security and it's compliant. Along the way, as you develop these, you might also want to look into managing Internet of Things solution with DevOps. Uh, Sometimes we call it IoT ops, where you can build and manage and provision and deploying code in a pipeline. And then overall, it's understanding the total cost of ownership. Yes, you can engineer different ways on how you would build an IoT solution. Some of them can be way, way, way too expensive. So it really depends on how you'd use the data that you collected and what is the total cost of ownership for that data that you're needing and the solution itself. Of course, we're all familiar with the Internet of with IT, which is the information technology. But also there's part of it of this that you have to merge with the operational technology. So what's the difference between the two? Informational technology, when we start talking about the CRM, help desk, cloud, ERP, software as service, a lot of the things that we're familiar with. Operational technology is, you know, it's been part of all the manufacturing systems and all the that's when we start talking about the SCADA systems, PLC, Internet of Things, the sensors, the actuators, and all these different machinery and assembly lines. There's data that's being collected there locally, and the people that actually maintains that, typically they're part of the operational technology. So we're trying to merge both the, not necessarily merge them, but there's things that you have to consider when you create an Internet of Things uh, system. Is there's the the combination of both IT side and the OT side. And there's different roles, especially when you're building an IoT system, that you have to think about. One is the administrator, that handles the administrative task, uh, assigning user roles, permissions, and the different things to for multi-tenancy, right? And then developer. A device developer is the one who writes the code for the IoT devices. Of course, there's software updates that might be needed, or if you have a third party that you are integrating with your Internet of Things systems, they may there may be some updates. So the device developer is responsible for those updates. And then the operator are the ones who manages the devices that are connected into your Internet of Things application. Uh, they typically are the ones who monitor what's going on. I mean, part of the operation operator technology or operation technology, right? And then you have the solution builder, which combines all these different devices and the cloud systems and how we would use the data that are being collected from that device into something that would be useful and something that would build the business, right? Build business value. Today, we're going to focus on the side of the solution builder. Of course, I'll show you different roles in IoT as we go along. So Azure has a way to simplify a lot of the different services or combine all these different services in Azure, IoT services in Azure, to simplify it to where we can connect and monitor and manage a lot of these IoT assets at scale. Uh, it allows us to have quick connectivity, be able to visualize a you know a service that we can visualize and analyze the data that we're receiving, a way to centralize to manage each one of these devices, and becomes a bridge between business application and then the IoT data. So what is IoT Central? IoT Central is responsible for managing devices, acquiring, connecting, and securing this. And that's how it can help us. Developers can use, or the solution builders can use that IoT data and customize it as what the business needs are. So, what are the benefits of IoT Central? Low code environment. There's fast and easy way for data analysis and visualization. So, of course, if you want something more, uh, there's also a way you can make it to where you can have more complex visualization, but there's already pre-built visualization for us, and we'll demo that a little bit later on. And then, of course, if you have something that is non-frequently changing data, and it also has a capability, IoT Central has the capability to have ready-to-use templates and as a good sample, and you can start from there. There's different types of device measurements, so depending on what you're trying to connect to IoT Central, what are different uh, things that you can get, data that you can get from device, and of course the measurement associated with that, and then authorization and authentication is already included in uh, in that service. So how you would leverage them? Of course, you have ways to collect data from your devices and then monitor each one of these. Imagine thousands or millions of devices and monitoring them. IoT Central helps you monitor these devices and the life cycle of these devices, and then analyze what's going on and the data that you're receiving from each one of these devices. And then, of course, the decision of what you would use based from that data that you collected. So, like, going back to my daughter, buying a kit for, or you know a, these mega blocks, right, and to build a house, not from scratch, but a pattern that she can start with, right? And that's what IoT Central is providing us. Of course, we're already familiar with infrastructure as a service and more familiar with platform as a service, which focused on software development and services. And we're some familiar with software as a service that is available out there. So IoT Central is application platform as a service, which is application focused software development services. There's a lot of customizations that you can do on an APaaS, or application platform of a service. And just like the same way as you have these Lego blocks, right? And you work with that instruction how to build that Lego blocks, or you have a starting point and you can customize uh, as need, as it fits the need. So IoT Central platform, application platform as a service, looks something like this. It's actually a collection of all these different IoT services that is in Azure, that builds it, that simplifies a lot of this and connects them automatically for you. For on the device side, you can use IoT SDK, Azure Sphere or RTOS to connect it to IoT Hub. So underneath IoT Central, it's using IoT Hub to receive those messages. In for the device connection, it's using DPS uh, to be able to manage it. And then in order to visualize it, where you have the hot path, the warm path, and the cold path, you can, it has ways to export the data from IoT Central, and then also have, it's using Azure Stream Analytics in the backend. It's using some of these services so that you can have this management web experience where you can manage your devices, you can view and analyze the device data and secure them, and then has a way to export the data that is inside IoT Central. So you can export it to Power BI, Azure Maps, Search, web apps, and then you can also trigger alerts, through Microsoft Flow or Logic apps. Or it has a REST API capability where you can control these IoT Central system, right? Each, and send data to that device, or you can query the status of each one of these devices or the management of it. All right. So when should you use IoT Central as compared to, IoT Hub and the provisioning, all these different Azure services? One is you have to look at the experience of your team. If your team is, they're new to IoT and they're not familiar with it, and they lack the skills and experience, which is very common because it's a new technology, also a new way of you know of receiving data and processing some data, right? And you have to consider the skills and the ability of your IoT team also. So do they specialize on devices, or do they, what is their specialization? And IoT Central provides you with enough customization and also ready to use applications. So maybe a starting point where you can have few of the customization option. And if you really need something that, okay, that IoT Central provides, you can actually build companion apps that can custom build the solution for you from scratch, and then have IT Central as your uh, backbone. And so, when should you use IT Central versus IT Hub? Sometimes IT Hub is a better option, especially for experienced professional that needs full control over their IoT solution. If they really want to know what's going on and doing some rerouting of the data that IoT Hub is receiving, that's when you wanted to do the IoT hub route as compared to IoT central route. So what made, or what, you know, here's some analogy. What made Windows very successful? We know it's successful because there's a lot of devices out there, or lot of laptops, computer that are using Windows, right? It's because, in my opinion, they worked with device manufacturer to have compatible devices. So when you plug in all these different systems together, right? All these different components, the DVD, the monitor, scanner, or however, disk drive, they have these, what we call device manager, that as you plug it in, it knows how to connect, right? And that's the magic of it. If you think about it in a bigger scale, same way as a lot of these Amazon devices that are available out there, right? When you plug in a new camera, a lighting system, for these, it's for your smart home devices, becoming a smart home operating system in a way. These devices can plug in and then seamlessly get data from one device, pass it to another device, and then be able to control it. And that's what Azure IoT Plug and Play is providing us. Azure IoT Plug and Play integrates this smart device solution without manual configuration. And I will demo how this one connects to IoT Central later on. And then this device model that advertises its capabilities to an IoT Central and eliminates that hassle of configuring each one of these devices by creating templates, adding features, and the interface. We'll give a little bit of example later on. The device catalog, there is a site, device catalog.azure.com, where you can find all these IoT plug and play. It's called the Azure Certified Device Catalog, where it gives you a guidance of, if you want to quickly find, a sensor or a device that you wanted to connect to IoT Central, and which one can you easily connect to. So there's different device types that IoT Central can connect to, right? An IoT device, an IoT edge device, or a gateway device. So let's try to figure out what's the difference between those three things. IoT device, typically it's a freestanding device. It sends sensor data directly to IoT Central. It has direct connection to IoT Central. It can send telemetry data, report its property values, or sometimes it can receive writable property values. That's when we talk about um, device twins. And then it can respond to commands. So if the cloud says, oh, reboot, and it would reboot that specific device. An IoT edge device, it also it's a device that directly connects to IoT Central. The difference is it has the ability to process more data locally, so you can kind of build typically you know containers or Docker images running on that edge device and process that data. You know, maybe some machine learning data. It does act as a standalone IoT device, or sometimes it becomes a middleman for other devices that can't directly connect to the cloud. And of course, IoT, a gateway device, is an IoT device that can connect to downstream devices and can be managed other devices that are connected to IoT Central. So it becomes kind of like a proxy when it does not have connection to the internet, right? Doesn't The gateway device has, it's kind of like a broker to where it can receive data from IoT Central, and then these devices can send it on a different, maybe on the different protocol, right? To send commands to specifically on an IoT device. So those are the three things. How you would connect a device to IT Central, it could be using a shared access signature. Think about it as a kind of like a connection string. It can use X.509 certificates in order to say, okay, this is, each one of the device have their own certificates, and they can do that handshake, how it would connect to to the cloud, or a trusted platform module. There's specific modules on the chip to be able to make sure that this device is what they say it is as it connects uh, the to IT Central. There's different communication protocols between the two. It can either be MQTT, AMQP, or sometimes HTTPS, secure communication between from the cloud to the device or device to the cloud. There's different device templates. What I mean by device template is the ability to create kind of like a blueprint definition of what the device, the data that you would receive on this device, right? So either it can either be one of these three. It's either telemetry data, properties, or commands. Telemetry data, this is when the device sends uh, data to the cloud. Every minute, every 10 seconds, send me the value of what I'm monitoring. Properties is somehow it's a read write property where the device synchronizes with the cloud, and sometimes we call this device twin. And sometimes you can set the properties from the cloud, and it would synchronize it to the device. So it's a two-way communication. And then, of course, when the device is down, it'll wait. The cloud would wait until it turns back itself back on, and the device would self synchronize those data set and resolve which one is the latest and greatest, supposed to be the correct value for that property. And then commands, these are cloud calls on that device. So the device have to be running or have to be available so that you can send command from the cloud to device and call it and execute a certain value or a certain command. So let's start with doing a demo of IoT Central. So if you go to apps.azure.iotcentral.com, it'll take you to this. There's actually some quick tutorial, and you might want to watch this in your spare time on how to kind of set it up. And it's a good tutorial on how you would do this. So what we're going to do today is we're going to build an app, and, and we're going to build this app, and then it will ask us, how do you want to build your IoT solution? There's existing ones already that it might be available. And if you're building an IoT solution that's close enough to one of these use cases, feel free to start with this because it would definitely help you understand. Might also give you a good guidance on how you would collect and manage these data. So it's not just for retail. There's also for energy. There's also for government, and there's also for healthcare. Today, we're going to focus on this custom app. We're just going to create one. And it will ask you a few things, right? The application name, the URL, there will be url.azure.iotcentral.com. It'll specify what custom application template it is. And of course, there's the pricing plan. And in each one of these, you can select. Today, I'm going to select standard 2. For each one of these plan, there's 2 devices that are free, and it tells you the difference is how many messages would you receive every month for each one of the device. And of course, it's cheaper if only receiving 400 messages per month, or 5,000 messages per month, or 30,000 messages per month. So it's up to you. And then of course, the billing, you can connect it with your Azure subscription, and then you just hit create. So I already made one, uh, and I call it simpler way. And what I'm going to do is I'm going to create a new device. So in how you would create a new device, you would do it this way. So you would device, and you hit new. And I'm just going to create this new device, and I'm just going to hit create. And don't worry about the template. There are no templates on this one. You just create. And what this one would do is it would start this device. And typically you won't receive any data, but since I already have that device ready in the background, uh, it started to connect to it. Okay. So so right now this is our device. How do we connect to this device? It would tell you right here. This is the ID scope, device ID, and then the primary key. So think about it. You can use a connection string. How you connect to this. So each one of these um, IT device have their own identifier. You can also use this if you just want to test this out and use your phone to be able to connect to a device. You can use a QR code. Okay, and that's pretty much what we need in order to create a device and connect it to IT Central. Let's go back to the presentation. So there's different ways in how you would monitor a device. You monitor the health of your application, an IoT and an IoT device. There's two monitoring ways. You can do device monitoring, which allows your device to identify what are the issues with them, and then the application monitoring side. And this is you can be part of Azure portal, or you can read it through REST API and what's going on with IoT Central application itself. So let's go back to my. Okay, let me walk you through some of the uh, things that you can do with IoT Central. You can connect devices. You can analyze some of the devices using Data Explorer or uh, dashboards. You can manage some of them through in creating jobs. You can extend the rules. You can do a data export. So data coming out of IoT Central, you can set permissions. So you can create organization and sub-organization. So think about having different locations where you locate or where you specify the devices are, or you can specify the users, roles, uh, the different roles. You can be an app builder, an app operator, or an app administrator, or maybe organization builder or organization operator. Um, you can have connection groups and how you would these devices can connect to IoT Central. You can have IO API tokens. This is where you specify the tokens and how you would connect to IoT Central. Application, you can have some different customizations. So how you what is the application ID, the and yeah, able to delete this application afterwards. You can have the appearance, change a little bit of the icon, uh, text, some of the help text and application text. So a little bit of customization what you can do on IoT Central as an application. Okay, I have these IoT sample code that I have in my GitHub, and this one right here is a temperature controller. Think about the kind of like a small IoT device in your home. And what this one does is it connects to IoT Central. So this is just a sample code out there. And it requires things in order to run. You would need uh, the IoT device scope, the endpoint, the security type, the device ID, and the device key. I filled that out when I created the device on IoT Central, and based from those values, I will plug this in on my launch settings. So you have to change this to launch settings.json in order to connect to that. Once I have these values, I can say .NET run. And what this code does, it will, once you run it, it would use that ID scope, the device ID and device key to communicate to IoT Central and then start sending some telemetry data. And let's go back to IoT Central and let's look at that. So if you click on devices now, notice how I still have my device ID, sample device ID, and then you have and it specified the device template. The device template, it created one. It's called temperature controller. And this temperature controller have all these different configuration. It knows what model. So this is based from this DTDL, which is the data definition language. And how it built this, as it connected, this is using the plug and play, IoT plug and play, where it reports itself what this device is capable of, right? And this is possible because this sample has this device information and it has this JSON file that defines, what is the ID and what type of device what can this device does support and sends to the cloud, the temperature controller, the like in this case the thermostat, what it's sending to the cloud, and what type of things it can do. So that makes it easy so that we don't have to go through each one of these settings and create these controller and then identify the capabilities of each one. So for example, the serial number, it is a property, it's a writable property, or it's reportable property, and then specify, okay, a reboot command, or in this case, the thermostat, how it's receiving the thermostat. It is a telemetry value, and this telemetry value, what type of schema it's using, the degree, or the unit is receiving it as degrees Celsius, and then the different properties that is available on that. Okay. So once you have devices, we know the device is connected, and then it created the device template. It also built a device group. A device group is all the possible devices under the same device template. So this, my machine right now is sending data to the cloud every few seconds. And let's go to that device. So I want to talk about a little bit of the analysis that you can do, or monitoring on some of these devices, right? We did talk about this device that connected to the the to our IoT Central instance, and you can see it reports the serial number, the manufacturer, device model, the software version. It also gives us, the reading, a small graph that this is based from the device template that you can do to, have some visualization. What is the average temperature for some of these, and then some of the commands that you can do. You can, the device template gives us that capability to send that, and you can read the raw data as it receives, right? You can see that right here, how it sent that JSON payload for each one of these telemetry. When it woke up, it had this device connected one, and it gave you the timestamp. So these are the data that it's receiving. You can do mapped aliases and files, mapping the alias from the raw data as you receive with the incoming data. You can also upload, have a capability to upload files to from device to the cloud. We can also do the data exploration side, where we can say, okay, I want to do my temperature controller. I want to specify the telemetry data and analyze it. And now you have a visual way of seeing what data have you received for the past few hours or past few minutes. You can create a dashboard. So let's say we want to create our own dashboard, a new one. You can do either personal or per organization. So in this case, I just want whoever's the user that is connected have their own personal dashboard. We can edit this. We can say, okay, I want to build a line chart, and this line chart, I want the last 30 minutes. How am I receiving data from this device group? The different instances of each one of these devices, right? And then the capability. So I want to do a graph of the average of the values that I'm getting from this thermostat, and has a way to visualize them. So this dot means, it wasn't connected, so it doesn't have all the values, and it start to connect it again. So at least have that ability to see the dashboard. All right, let's go back to our presentation. So we did a little bit of the demo on the IoT central device monitoring, where we have a way to visualize some of the data, creating a dashboard. Let's talk about jobs. Jobs is a way to manage connected devices at scale, where you can do device properties, cloud properties, you can run commands, you can change device template. You can even use a CSV file to import and export devices in bulk to do this. So if you want specific devices that you want uh, to manage, so it would look something like this, where you can go to jobs, configure it, specify the name of what you're trying to do. You specify the device group, in this case, all my temperature controllers, and I want to change the property, the target temperature. In this case, I want to specify, yes, I wanted to change it to 25. And so what it'll do is it would set that property, and then once a device receives it, once I run it, it would send this property, set this property of thermostat one, target temperature to a specific amount, and it would start receiving that value and give you the result. And once it's done, it would tell you if it actually did it or it failed, And there's a lot of customizations that you can do here too. You can schedule it. You can say, okay, if it, if you have, imagine if you have thousands of devices that you're updating some of their properties or changing the device template, and then and some of them failed, you want to stop the batch job, right? So those are the different capabilities of how you can do on that. Extending to IoT Central, there's a way you can export the data, you can build rules or REST API. Exporting the data, you can do email, webhook, Power Automate. You can use it with Azure Monitor, Blob Storage. So a lot of the customizations in Azure, a lot of these services, you can forward these data as you're receiving from the devices, and then and send it to a different Azure service. You can also use APIs, and when you build your companion app, use a lot of the APIs to control some of these devices and get some info on them. So data export allows you to export it to an event hub where you can process and transform millions of events. This, of course, service hub is when you want it uh, step by or organized or uh, not organized. More, it's more if you want it as you want it in certain order. And you want to know for each one of the orders. You can export the data into to to a blob storage if you want if you want unstructured data, and then you can build it later on for visualization. And then you can also do Azure Data Lake, where you can process and analyze large amount of data. Today, I'm going to focus on the webhook and just trigger HTTP callbacks to the to other application where we define the rules. In terms of if you want to do data export, you can specify the destination. In this case, we wanted to use a webhook, and then we just specify our URL where we want it to point to, and then we can, in this case, this URL does not need any authorization, and you just send that. So any data that you're receiving and you're exporting, send it to here. And then on the data export side, you would specify, okay, um, in this case, I want to know only devices that has device name that contains the word sample. So because let's say if you have thousands of devices, you can filter what type of devices, right? Or and then in this case, what type of data you want to export. You can export telemetry. In this case, I'm exporting device connectivity events. So when the device wakes up, it would go through this data export, and then we can call a different API. And then in this case, I also want to do an enrichment. An enrichment is data that you want to additional information that you want to export. In this case, I want to export the organization, what organization it belongs to, and then the some random custom string is a sample, is it true, that kind of thing, right? So it'll get passed to my output, and then specifying the destination. So let's say in this case, I specified based from the destinations that I specified, and then we can do more data transformation, and then that's when it starts sending it. So let's look at the data transformation side. So what can you do with data transformation? You can have telemetry values where you can restructure some of the JSON payloads and then rename the fields. Sometimes you can filter out the fields or run simple calculation. So the data transformation side, you can have these. This is a simple example where instead of receiving every possible property of that of that device, or every possible data that is being sent from device to cloud, you can filter them, um, and then based from that filter, instead of a bunch of data, you can just filter it to where you have your enrichments, you have your device name, then or the template name with the serial number, and then the type. So in this case, I want to get the serial number as part of the properties. So typically, what it would look like. So I want to show you. So just to visualize it. So what we did here on data export, we created this destination. You can have different destination. Um, we specified the URL of where we want to send, and then the data export side, we specified the connectivity. Like in this case, I only want devices. We did talk about the enrichment side, and then the data transformation. This data transformation, uh, it looks like this, and this is interesting because it gives you a sample what the input messages would look like coming from IoT Central. Uh, so it would, so if without data transformation, it would look something like this, and you still need to filter it, and however you want to use it. This transformation query is using JQ. So instead of receiving it this way, you can, with some of the customizations you can do, specify device name, and like in this case, I'm searching for the serial number out of the device properties reported. I filter them out, and I want to search for the serial number, and I just want to get that value, and that's what gets assigned here. And so once I have that, my data set would somehow look like this. Of course, a device would maybe, since this is a sample data, it would send it to you in a different way. It would tell you the template name, now the serial number, whatever that value is, would get processed, and then like in this case, I'm doing device connectivity, and then it filter it and send it to your data to your device. Oh, to the webhook. So in this case, data that you receive from device, it went to IoT Central. IoT Central would format it specific way, like this, and then based on this value, we filter it with the transformation query, and then on the other end, as you receive this data, it would look totally different. Okay, let's go back to the presentation. So rules. Rules is when you want to notify operators what to the other system. This is when you start looking at the business process flow and monitoring the alerts on a custom dashboard. Right? So rules, in this case, you can create when the temperature hits a certain level in a 5-minute span. That's what what I want my rule to be. So I can say I want to specific device template, our temperature controller template. I specify only the ones that has a serial number that contains SR. So I can filter them down if I want to limit what I'm monitoring. So in this case, I want to do time aggregation, that if the temperature is greater than specific, that hits a specific amount, like in this case, 35, if it hits that one, then um, then I can, of course, you can have multiple conditions as you set them up, and then once you have of those multiple conditions, one, like in this case, if all the conditions this gets triggered, then I can do a webhook and send it to a different location, right? I can do a webhook, or you can do You can send it to Azure Functions, Flow, or Logic app, or your application. You can send it, you can have it to where you can send an email, you can do an Azure Monitor, or you can do Power Automate. So it opens up a lot more things that you can do on this. Of course, there's specific format as to how you would receive it. If it's an email, there's a certain IT Central email template that they would receive. If it's, you can also do SMS, and you can specify, how you would want to format it. And of course, they were doing webhook if you want to do that. And then you can build the rules that way. Okay, moving along to REST API. So if you're building a companion app, you want to do some of the management through REST API, where you can do app management. You can do device onboarding through the REST API. The device modeling can be done through REST API. The device management and some of the data insights and all that. So in order to do this, you would go to security, and then you want to get permissions. You want to get that API token and then you specify the role, and it would generate a token that you would use in order to send it to communicate with IoT Central. So one good example is you can specify um, a patch. You send this, and you specify /API/devices/sample device. So I'm specifying the device I'm communicating to. I want to change the property of that device, and of course it's also version. Their API is version, so that um, they can have different from one API to another. They may be able to they might be changing. So you look at the you can look at some of the documentation on that, which API you would use. In this case, the body of our API, we want to send the property and change the thermostat property. And we specify the target temperature, the specific amount, and then it would give us a sample response. So let's look at this real quick. Let's go back to our IT Central. And then let's look at how this device, right? So this device right now, we know that the target temperature is set to 0. There's no target temperature. The temperature that we're receiving right now, it is, I guess, 41, right? And what we want to do is to lower it down. You can do this manually here, where you can specify uh, value that is desired and reported. How you would do that? We talked about it. We specify you can create a job, and we can run the job to change the desired property, and then it would change that temperature. So what we're going to do is we're going to do it through the API. So I have my this patch that I'm sending, and I'm sending this value. I want to change it to 20. So I'm going to call this API and send that request. And so this is what it gave me back. It told me that it looks like it's successful. It changed the value. How do we know that? Is if we go back here, see, notice how the target temperature have changed, and the device have accepted it and reported that that's what that it's going to do, that it's going to change the property value of the target temperature to 20. And notice how my current temperature have dropped, and it listed that it's set to 20 now. So because it's kind of like you change the target temperature, and then the system would progress and change it accordingly. Okay, so that's an example on how you would uh, use the REST API. There's a lot of things you can do with the REST API. You can control device, you can create a device, you can create jobs, those kind of things. So, industrial Internet of Things. So you're not just limited to what you can do with IoT Central. If you have devices that have different communication, um, you can have a gateway that talks to those assets. So SCADA machines, some of those. And then you can go through the gateway to be able to communicate to IoT Central, and then get some business insights from there. So, in summary, what is Internet of Things? It's being able to remotely monitor and control the device. An IoT Central is simplifies the creation of an IoT solution. We did talk about the benefits of IoT Central. A lot of it is a lot of low code environment and a lot of application platform as a service type of of service. Um, we did talk about a bit about device template, the difference between what is a telemetry data, what is a property, and what is a command. Uh, IoT plug and play. We did talk about the device catalog, where you can find existing devices out there that might that you can help you get started. Visualizing data. Talk about how to create dashboard and the, the ways and how you can monitor some of what's going on with that device. Integration. We did talk about rules, the data export, and the REST API. Gave you examples on how to create the rule, how to do a data export, and how we would use the REST API for our companion apps or to extend its capabilities. If you want uh, to get the slides or the application, the code that I did showcase today, feel free to go to my GitHub or scan this QR code. If you want to learn more, there's a lot of I would recommend going to Microsoft Learn to be able to know more about what IoT Central can do. There's a REST API documentation that is available there. If you want to see some just examples of other things that some of the utilities that are built around IoT Central, you go to Awesome IoT Central. It is on GitHub. And if you want to manage application REST Central with REST API, there's also tutorials out there that is available for you. A little about me. My name is Ron Dagdag. I'm a director of software engineering at Spacey, and I've been a Microsoft MVP awardee for 6 years. This is my sixth time. My email is ron@dagdag.net. You can contact me through LinkedIn. I appreciate you geeking out with me with all things Internet of Things. Of course, a little bit of Lego and a bunch of IoT Central. And I appreciate you spending time with me, and have a good day. Thank you.